you all are well aware about the solar panels you have seen on our rooftops, buildings. But have you ever wondered what happened to the end of life? So typically, till now, there is no recycling technique is available which is commercially viable as well as environmental friendly. So as a result, they are end up as a landfill. Landfill is not a good because it is harmful for the environment as well as we are losing lot of valuable materials also. So for example, silver, around 14% of total world's demand silver is using by the solar industry as of 2023. And with the time it is increasing. So how the material distribution occurs in a panel, what type of materials are there. So we can see here by weight, almost glass covers 75%. If we see the by value, so it is around 8%. But silver, that is less than 1%, but its value is approximately half of the price. So it becomes very crucial to find out a technique which is suitable for the recycling. So our problem statement, as solar technology is expanding rapidly, so by 2050, we can see a huge mountains of the PV waste. So it become very challenging to figure out that waste. And the raw material for that waste is around $15 billion. That's a huge amount. We can generate a lot of new industries, a lot of new employments. However, some techniques has been proposed to recycle these, like chemical methods, thermal methods, and mechanical methods. But all these methods are not very much commercial viable as well as not environmental friendly. So what if you see a technique which is having both environmental friendly as well as commercial viable? So here we are going to use lasers technology for recycling of PV modules. So laser is well-established technology in semiconductor industry, in the automobiles, biomedicals, and various other fields. For the first time, we explored this technology for our solar recycling. So this is the typical solar structure. It has different layers. So in the mid, there is a glue, I call this. This is called encapsulant. This strongly bond all these materials. During the recycling, it is challenged how to make debond from that layer. So laser has beautiful properties like we can focus at particular point and we can deliver all the energy at that point. We can change the material properties and we can easily separate from them. So this is the experimental setup, how the laser is coming onto the samples. And after that, it becomes very easy to debond it. And with the debonding, we are able to recover glass, silicon. And when we compare the cost also looks very attractive because in our case, we reached less than 1% cost of the new material. So, and the same way, as I said, silver is most prominent material in the solar panel. And so for the silver also, we use the same setup. You can see these small lines are the silver line. So what laser do? Laser directly focus on these lines. It makes very small particles. Like our hair is in micron order, and this is in nano range. So we can directly convert these particles as a nanoparticle. And these nanoparticles are very high purity, and we measure the cost. Cost also looks very attractive, like 35 cents per gram. And if we are going to purchase new, that will be somewhere around $5 to $12 per gram. So this looks very promising for the industry perspective. So conclusion, using this technology, we are able to recover almost all the material like glass, silicon, silver. And now we can say goodbye for this solar waste. So like we can recover all the materials. And third thing is, this is quite commercially viable technology. Like we are talking with some industry leaders as we already filed the patents. So we are in the technology transfer working on that. And the last and best part is still our planet is safe because this technology doesn't contain any chemicals or any gases. So it looks very good for the environment. So thank you very much.